Hi students, welcome back to another video session related to the data structures. This is the second BSc Computer Science 4th semester paper. This is Lakshman, lecturer in Computer Science from BRR and GK Campus Degree College, Palakollu. Today I would like to discuss about the linked list and its types. So in the previous section we are already discussed about what is linked list. So how the node is represented in the linked list can be discussed in the previous session. Now we have to discuss about the types of linked list. So linked list can be divided into three types of linked list. So one is single linked list, double linked list and circular linked list. So these are the three types of linked list. One is single linked list, double linked list and circular linked list. So what is single linked list? Single linked list is a list in which each node linked with other. One node is linked with the other in linked list. So this is one node, it contains two parts. So this is another node, it contains two parts. Okay, how these two nodes are linked? For example, I want to store two values here. So one is 10 and 20. So these are the two actual values stored in this node. So this is the data part, I am storing 10. So this is data part, I am storing 20. So how can we link these two nodes? Means the address of the node, that is 1002. For example, assume that the address of this node is 1002 and address of this first node is 100. Okay, that means the address of the next node is stored in this location, that means 1002. That means these two nodes are linked with each other. So this is how the linked lists are working. That means these nodes are linked with these nodes. That means the first, the address part having the address of the next node. So actually this value, this node contains the null value here. So if you want to store one more data here, that is 30. Okay, you have to create one more node, so that is 30. So 30 is stored here. How can we link these two? For example, assume that the address of this node is 1004. Okay, 100. The 1004 is stored here. That means these two nodes are linked with each other. So the node in the list need not be stored in contiguous memory location. So this is not the contiguous memory location. So it is the locations can maintain at anywhere in the memory. A node can contain any number of data fields but only one link field. Any number of, but the address is only one. In a node there may be any number of data fields and only one address field. So we have to maintain any number of data fields. Okay, any number of data fields, but the address field is only one. Okay, so this is the node structure of the single linked list. So class node, so this is the node, this is the class of type node. It contains two parts. One is a data, that is integer, we are maintaining int data. Link, that is address, that is of type node. Okay, it contains two parts. One is the data part and the link part or address part. Okay, the data part contains the actual value or actual data. The link part contains the address of the next node. The address part having the address of the next node. This is the actual structure of the node in single linked list. It contains two parts. One is data part and the link part. Next, so for example, so this is the node, this is the first node, this is second node, third node and fourth node. I am storing the values 10, 25, 18 and 55. So how can these two nodes are linked? That means the address of the second node is stored in the first address field. Okay, next, so how can we link these two nodes? The address of the third node is stored in this location. Okay, so these two are linked, that means this is the address of this node 1012 is the address of the fourth node, which is stored in the third node of the address field. The last node address field must be contain null value. Okay, this is the single linked list representation. So this is the front or head part which contains the first node address. This is the first node address. This is the head part or front part which having the first node address here. Okay, so the address of the fourth node is stored in the link field of the third node. The address of the third node is stored in the link field of the second node, and the address of the second node is stored in the link field of the first node, and the first node address is stored in the pointer called as head. So this is the head or front. The last node of the single linked list holds the null value. So the last node must and should contains the null value in the link field, indicates the end of the field. If the last node address field having the null value, this is the end part of the linked list. So what are the operations performed on linked list? So majorly we have to perform three operations. One is insert the data, deletion the data, and you have to display the data here. Okay, so this is the single linked list. Next one is a circular linked list. So we have to maintain in a circular manner. Okay, like a single linked list, we have to maintain in a circular manner. So this is the first node, second node, third node, and fourth node. So the actual values are 10, 15, 22, and 50. The first node address, this is the first node address 1002, 1004, 1008, 1010. So by clearly observe this, the address of the second node, that is 1004, is stored in the first location. The address of the third node 1008 is stored in the second node. The address of 1002 is stored in the third node. So actually we have to end this linked list. Okay, if you are storing null value, this is the null. But in circular linked list, the last node contains the address of the first field. That is a circular linked list. The last node address field contains the address of the first field. Observe this, 1001 is the first node address. Here we are maintaining the 1001. That means the first node address is stored in the last field of the linked list. We have to maintain the circular manner. So this is the circular linked list. So in the circular linked list, the last node of the list contains the address of the first node and forms a circular chain. So what are the operations of the circular linked list? One is insertion, deletion, and display. Okay. Next one, double linked list. So in the single linked list or circular linked list, it contains only two parts. One is the data part and next one is the next part or link part. Okay, but whereas in double linked list, it contains the three parts. So having the three parts, one is the left node address and the right node address, and this is the data part. So it contains the three parts. One is the first left hand side address link, right hand side address link, and the data part. Okay, so this is the structure of the double linked list. In a double linked list, each node contains two references to the previous and the next node in the sequence of the node. So in double linked list, every node can maintain the previous node address and the next node address. That is the double linked list. Hence double linked list can traverse in both directions and two pointers are used. So that is the left pointer and the right pointer. So what is the structure of the node here? So class node, so int data, it contains two links. One is link 1 and link 2. So link 1 having the previous node address, link 2 having the next node address. Okay, so this is the structure of the linked list. So link 1 and link 2, so that is the data. Okay, Here link1 field is used to store the address of the previous node in the sequence. Link2 field is used to store the address of the next node in the sequence, and the data field is used to store the actual value of the node. Okay, so in this example, the first node left hand side address is null and the last node right hand side address field is null. We have to maintain this. So the first node, this is the last node, so the values are 10, 29, 35 and 15. So in the same way, so this location contains the address of this field, this node contains the address of the previous field. For example, 1000, here address 1001, 1002, 1003. In this location it contains the address of the previous node. This is the previous node, this is the previous node, the address is 100, the 100 is stored here. In this location the address of the next node, for example 1002 is stored. In this location the address of the next node. So there is no another node here, that means the right hand side address field contains the null value in the double linked list. In this way we have to maintain the data either in single linked list or double linked list or circular linked list. We have to maintain data very very efficiently, and we have to access the data very effectively. So what are the operations performed on double linked list? One is insertion, deletion and the display. So we have to insert the data, we have to delete the node, we have to display all the information of the linked list. Okay, so what are the, and the next one is what is the difference between array and the linked list? Okay, so array and the linked list. So this is an array and the linked list. What is the meaning of array and what is the meaning of linked list? Okay, so both are sequential representations. Okay, array is a collection of elements having the same data item with common name. Okay, already know array is a collection of similar data items, whereas a linked list is an ordered collection of elements which are connected by links or pointers. Okay, so this is the contiguous block of memory, but linked list is not the contiguous block of memory. We can link or we have to use pointers. We have to link the data in linked list. Okay, how can we access? In arrays, the particular value can be accessed by index or subscript. In linked list, the elements cannot be accessed randomly. We can access only the sequential, and accessing elements take order of n times. So there is no directly accessing the elements in linked list, but we can access the data randomly in arrays with the help of subscript or indexes. Okay, so what is the memory structure? In arrays, elements are stored in consecutive memory in these locations. In linked list, elements can be stored at any available place as address of the node is stored in the previous node. So this is the structure. This is the contiguous block of memory, but linked list is not the contiguous block of memory. We have to link the one node to another node with the help of pointers. Okay, so how can we insert and deletion? So insertion and deletion takes more time in arrays as elements are stored in consecutive memory location. So if you want to insert an element in any particular location, the time taken is very high in arrays. So insertion and deletions are fast and easy in linked list, or only value of pointers is needed to change. Okay, next, memory allocation. In arrays, memory is allocated at compile time, that is static memory allocation, but this is the linked list is the dynamic memory location. The memory is allocated at the time of runtime. Okay, so in linked list, memory is allocated at runtime, that is dynamic memory allocation. So arrays are two types, one is single dimensional, two dimensional or multi-dimensional, but whereas linked list are single linked list, double linked list and circular linked list. Okay, so in arrays, each element is independent, no connection with the previous element or within its location. But whereas in linked list there is a dependency between the nodes, that means the every node having the address of the next node, that is a link, there is a relationship between one node to another node. In linked list, location or address of the element is stored in the link part of the previous element node. Okay. In arrays, no pointers are used like linked list, so need not to extra space in memory for pointers. But whereas in linked list we have to use pointers, we have to allocate some memory to pointers also. In linked list, adjacency between the elements are maintained using pointers or links, so pointers are used for that extra memory space is needed. So this is the how the data is stored in arrays. So you are allocating the memory in a contiguous block of memory, but whereas in linked list the data is stored in like this. One node is linked to another node, every node contains the address of the another node, we have to maintain the linked list. So I hope you are understood this concept. Thank you.